Alright, I'm sorry I said that was the last of the tutorial. I don't know why I thought that. Module number 11. Brief Tour of the Standard Library. Part 2. The second tour covers more advanced modules that support professional programming needs. These modules rarely occur in small scripts. Output formatting. The reprolib module provides a version of the repr function customized for abbreviated displays of large or deeply nested containers. And if you recall that the repr function returns a representation of an object that ideally could be itself passed into the eval function, and that would return the original object passed into the repr function. And that's what differentiates it from just the print function, for which the priority is just human readability. And this can give you an abbreviated display. For instance, we pass in the set of the string supercalifragilisticexpialidocious. The repr of that would be pretty long, but using the reprolib, we get up to G, and then we get ellipsis dots indicating the rest of it. The pprint, which stands for pretty print, module offers more sophisticated control over printing both built-in and user-defined objects in a way that is readable by the interpreter. When the result is longer than one line, the pretty printer adds line breaks and indentation to more clearly reveal data structure. So for instance, in this case, we've got this ridiculous, look at this bullshit, how many nested, this is lists upon lists upon lists, pretty hard to parse upon first glance. Pass it after setting it to a variable, along with a specific width argument into the pprint, and we have here something that at least a little bit clarifies where each bit is, The text wrap module formats paragraphs of text to fit a given screen width. So say we give it this big old multi-line docstring that says the wrap method is just like fill, except that it returns a list of strings instead of one big string with new lines to separate the wrapped lines. So it simulates text wrapping. The locale module accesses a database of culture-specific data formats. This is interesting. The grouping attribute of locale's format function provides a direct way of formatting numbers with group separators. So in this example, you access the English/United States conventions, and then once you've done that and set that to the English/United States, it returns a dictionary that contains as key value pairs the conventions, that you can then, once setting it, you can later call it. Like here we've got this just long string of numbers here. You can format it using the local conventions, and if you want to specify the convention at key currency symbol in this particular database of the English United States conventions, the currency symbol, or the value associated with the currency symbol key in this dictionary is of course the $. And so you can just automatically format with those conventions of a given place just by calling the same key. It'll return the values unique to those conventions. That makes sense, Templating. The string module includes a versatile template class with a simplified syntax suitable for editing by end users. This allows users to customize their applications without having to alter the application. The format uses placeholder names formed by the $, with valid Python identifiers, alphanumeric characters, and underscores. Surrounding the placeholder with braces allows it to be followed by more alphanumeric letters with no intervening spaces. Writing $$ creates a single escaped $. And this is true in so lots of other cases too, that sometimes if a symbol is a formatting thing, it means something will be interpreted and not printed as is. Often just doubling it will be interpreted as, okay, we'll show a single $. Here. So for instance here, we've got a replacement field that we can substitute with Nottingham. That wasn't necessary with this, but you had to put $2 signs so that the final output actually displays $10. And here, just the dollar sign before cause allows you to, using the dot substitute, replace cause in the input string with the ditch fund. So this will get Nottingham folks send $10 to the ditch fund. The substitute method raises a key error when a placeholder is not supplied in a dictionary or keyword argument. So for mail merge style applications, user-supplied data may be incomplete, and the safe _ substitute method may be more appropriate. And it will just leave the placeholders themselves unchanged and the output of the data is missing. So for instance, if we tried to just substitute, where we've got this template that wants information about item and information about owner that it'll be able to format in the final output. Here we've got a dictionary that only answers the call of the item. It neglects to tell us what the owner is, and if we pass that into dot substitute, then we'll get a key error because where the hell is the owner? But if we pass the same thing into safe substitute, then it will accept what we did pass in, and it won't raise an error that we didn't fill this one. It'll just return the placeholder unchanged. Template subclasses can specify a custom delimiter. For example, a batch renaming utility for a photo browser may elect to use % signs for placeholders such as the current date, image sequence number, or file format. So in this example, we've got, after importing time and os.path, created a list called photo files containing these three strings, these file names, right? And made a class called batch rename that inherits from template, making it a template subclass, which means it can specify a custom delimiter. In this case, the % sign. Now, we make a new variable set equal to the input received from the user in response to enter rename style and then this formatting, right? And the response the user gave is Ashley _ %n%f is defining the whole formatting of the batch renaming. We pass that in to batch rename to create variable t and use the string format time of the time module to interpret this formatting information. And then we iterate through the enumeration of photo files, split the text, use the substitute method we talked about earlier, and we print with the formatting. And this will make each file in this list renamed to begin with Ashley, followed by an underscore and the sequence number, so the starting at 0, counting upward, and the format, that is a .jpeg file. Another application for templating is separating program logic from the details of multiple output formats. This makes it possible to substitute custom templates for XML files, plain text reports, and HTML web reports. Working with binary data record layouts. The struct module provides pack and unpack functions for working with variable length binary record formats. The following example shows how to loop through header information in a zip file without using the zip file module. Pack codes H and I represent 2 and 4 byte unsigned numbers, respectively. The less than sign, or left pointing chevron, indicates that they are standard size and in Little Indian byte order, so that the least significant byte is stored at the lowest number in computer memory, the lowest number spot in computer memory. I'm still not clear on what the difference is between saying Little Indian and just saying descending order, or Big Indian and saying ascending order. I'm sure it has some greater significance than that, but that's essentially what it means, is that it's little at the end. So we could, the result of opening myfile.zip in this mode, and setting that as the variable f, and then using the .read method on that, setting the result of that to the variable data. Oh my god, is somebody calling me right now? I'm going to be real with you, I'm just going to have to take them at their word that this following example shows how to loop through header information in a zip file without using the zip file module. So I'm not really following this at this point. Probably don't have to yet. Multi-threading. Threading is a technique for decoupling tasks which are not sequentially dependent. That is, that they don't need to be done one after the other and are dependent in some way upon that sequence. Oh my god, somebody's calling me again. Threads can be used to improve the responsiveness of applications that accept user input while other tasks run in the background. A related use case is running I/O in parallel with computations in another thread. The following code shows how the high-level threading module can run tasks in background while the main program continues to run. I just want to get to reading the standard library because this tutorial really doesn't assume that you're actually beginning at all. It just sort of states things like, the principal challenge of multi-threaded applications is coordinating threads that share data or other resources. To that end, the threading module provides a number of synchronization primitives including locks, events, condition variables, and semaphores. While those tools are powerful, minor design errors can result in problems that are difficult to reproduce. So the preferred approach to task coordination is to concatenate all access to a resource in a single thread. I'm sorry, that said, concentrate. Is to concentrate all access to resources in a single thread and then use the queue module to feed that thread with requests from other threads. Applications using queue objects for inter-thread communication and coordination are easier to design, more readable, and more reliable. Logging. The logging module offers a full-featured and flexible logging system. In the earlier versions of Python, you actually had to get a truck and drive out to the woods and fell trees yourself. And now in Python 3.12.3, they have very convenient tools that will help you log just from the comfort of your own home. At its simplest, log messages are sent to a file or to sys.standarderror. So you can log things, you can set the messages, you can format the messages and whatnot. This will produce the following output. Seems pretty self-explanatory. By default, informational and debugging messages are suppressed, and the output is sent to standard error. Other output options include routing messages through email, datagrams, sockets, or to an HTTP server. New filters can select different routing based on message priority: debug, info, warning, error, and critical. The logging system can be configured directly from Python, or can be loaded from a user-editable configuration file for customized logging without altering the application. Weak references. So Python does automatic memory management, reference counting for most objects, and garbage collection to eliminate cycles. The memory is freed shortly after the last reference to it has been eliminated. This approach works fine for most applications, but occasionally there is a need to track objects only as long as they are being used by something else, and unfortunately just tracking them creates a reference to that spot in computer memory that makes them permanent. That memory won't be freed up until the garbage collector sees that nothing else is referring to it. And the weakref module provides tools for tracking objects without creating a lasting reference. When the object is no longer needed, it is automatically removed from a weakref table, and a callback is triggered for weakref objects. typical applications include caching objects that are expensive to make. So for instance, here, defining this class A, which will take in a value passed in any instance created of it, takes in a value as an argument, assigns that value, associates it with that instance, and returns a string version of that, right? So we create an instance of class A here, A with 10 passed in as value, and we set that equal to this variable A, and we set D equal to a weak value dictionary created from weakref, right? And if we update the value of, we update this dictionary at key primary, we associate the value A, this instance of class A, then we can call that key in this dictionary for now, and it will return this. It's holding, it refers to that in a sense. But if we delete A, then we can immediately run the garbage collector, and we check for that. We check that key again, D primary. Then there's nothing there. It was automatically removed, even though we had that reference to it. And if you just did that with a regular dictionary or whatever, then that's it wouldn't be able to clear up that spot in computer memory because there's a lasting reference to that spot in computer memory. Tools for working with lists. Many data structure needs can be met with the built-in list type. However, sometimes there is a need for alternative implementations with different performance trade-offs. The array module provides an array object that is like a list that stores only homogeneous data and stores it more compactly. By the way, homogeneous and heterogeneous are both pronounced homogeneous and heterogeneous. It's not homogeneous, it's not heterogeneous. There's no I or Y or E or anything after the C. G-E-N-E-S is confusing. I guess there is kind of, you could say. Homogeneous. Wait a second. What am I thinking of? I know it's pronounced homogeneous, though. Hold up. Okay, wow, my mind was blown there for a second because I was certain there was no E there, and there's not in American English spelling. Apparently in British English there is. But I'm talking to my fellow Americans who read the American English spelling with no E after this N and say it homogeneous. Doesn't make any sense. And stores it more compactly. The following example, nobody's watching this anyway, shows an array of numbers stored as 2-byte unsigned binary numbers, type code H, rather than the usual 16 bytes per entry for regular lists of Python integer objects. So, I'm not really clear what that is supposed to do. I guess, 2-byte unsigned binary numbers is obviously going to take up less space than 16 bytes per entry. I guess if something's more memory critical and you're worried about optimization, then this might matter at some point. But, this H here defines that you're going to change everything in here into 2-byte unsigned binary numbers. That's about it. The collections module provides a dequeue object that is like a list with faster appends and pops from the left side, but slower lookups in the middle. These objects are well suited for implementing queues and breadth-first tree searches. Since we talked about this already earlier in the tutorial, in addition to alternative list implementations, the library also offers other tools such as the bisect module with functions for manipulating sorted lists. Interesting. So like here, so yeah, okay. So to bisect something is to split it in half, is to cut it in half, literally. well, it's to cut it into two pieces, technically, not necessarily cut it in half. So it appears that using that, we can introduce a new tuple into a list of tuples that is sorted already. We can introduce it directly to where it should go. In this case, being 300, should go right here. And using bisect.insort scores of this tuple, 300, comma, Ruby, call scores again, and we see it has been placed right here, exactly in the middle, like it was cut open. The heap queue module provides functions for implementing heaps based on regular lists. The lowest valued entry is always kept at position 0. This is useful for applications which repeatedly access the smallest element but do not want to run a full list sort. So say we got this just random bunch of numbers in this list. We can heapify it. We'll rearrange the list into heap order, which puts the lowest valued entry at position 0. We could add a new entry, and it will automatically be placed correctly, right? Heap pop data for I in range 3. No, it wouldn't. So making it a heap sorts it with the lowest at the lowest, but then you can add stuff to it and it'll not be in order? The fuck? Apparently it's like a tree structure. Decimal floating point arithmetic. The decimal module offers a decimal data type for decimal floating point arithmetic. Compared to the built-in float implementation of binary floating point, the class is especially helpful for financial applications and other uses which require exact decimal representation, because math with floats can return some weird stuff. There's just weird side effects of the way that numbers are represented in that way, that they're typically like can approximate very, very closely how math actually works, but if you really need a lot of precision, they actually don't. Computers doing math with floats or get real weird results sometimes, where like 1 is equal to 1.000002 or whatever. Control over precision. Control over rounding to meet legal or regulatory requirements. Tracking of significant decimal places, or applications where the user expects the results to match calculations done by hand, which I feel like in all mathematics you kind of expect that, right? For example, calculating a 5% tax on a 70-cent phone charge gives different results in decimal floating point and binary floating point. The difference becomes significant if the results are rounded to the nearest cent. I mean, we get an entire cent difference in these two approaches, which would certainly add up and be important in certain circumstances. The decimal result keeps a trailing 0, automatically inferring 4-place significance from multiplicand with 2-place significance. Decimal reproduces mathematics as done by hand and avoids issues that can arise when binary floating point cannot exactly represent decimal quantities. Exact representation enables the decimal class to perform modulo calculations and equality tests that are unsuitable for binary floating point. For instance, if we try to do decimal 1 modulo decimal 0.1, which should be 0, right? Wait a second. We'll get the correct answer 0. Whereas if we use a binary, 1 modulo 0.1 will return 0.09999999995, which is, totally fucking not true. This still seems wild to me. And like here, if we say add 1/10 to 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 1/10, does it equal 1? False? What? Computer? So using the decimal, we would get true, as it obviously is. Computer? The decimal module provides arithmetic with as much precision as is needed. Get context.precision, x36, decimal 1 divided by decimal 7, and we will get the true honest to God precision. that all mathematics aspires to which all mathematics aspires.